In this video, I'm going to talk about even and odd functions over the real numbers. Even and odd are describing certain symmetries of a function. Unlike for integers, even and odd for functions are not bivalents. A function can be even, can be odd, can be neither even nor odd, or in a very special case, it could be both even and odd. So what is an even function? A function f is even if for every input value x, if you plug in negative x into the function f and calculate the output, or you plug in x into the function and calculate the output, they always give you the same value. This looks very complicated and difficult to understand, but let's take a look at the following graph. When the input value x is 1, according to the definition of an even function, f of 1 and f of negative 1 should have the same height in the graph to reflect the condition that the output values of f of 1 and f of negative 1 are the same. Similarly, f of 2 and f of negative 2 should have the same height. F of 3, f of negative 3 should also have the same height. Continuing this analysis, we will see that if the graph of f of x looks like this on the left-hand side of the y-axis, then on the right-hand side of the y-axis, we should have the exact same curve except that it is now reflected. And hence, we know that an even function will always be symmetric across the y-axis. So now, what is an odd function? Just like an even function, we will study the output value of f negative x. A function f is odd if for every value x, f of negative x is equal to the negative value of fx. Once again, this looks quite abstract, and let's take a look at the following graph. When x is 1, if this is the value of f1, then f of negative 1 should be the negative of this value, and so we will have a point here on the graph. If this is f of 2, then f of negative 2 should be the negative of this value, so we will have a point here on the graph. If f of 3 is somewhere here, then f of negative 3 should be the negative of this value, so it would be somewhere here. How about f of 0? When x is 0, this identity gives us f of negative 0 equals to negative of f0. Because negative 0 is simply the number 0, we obtain that f of 0 equal to negative of f of 0. The only number in the world that would be equal to the negative of itself is 0. Therefore, f of 0 must be the output value 0 here. Continuing the same study for different values of x, we found that if the graph of fx looks like this on the left-hand side of the y-axis, then on the right-hand side of the y-axis, the graph would look like this, which is a rotational symmetry about the origin. Here is a quick summary of what we just learned about even and odd functions. For even functions, the value f of negative x is always equal to the value f of x, and the graph is symmetric across the y-axis. While for odd function, f of negative x is always equal to negative of fx, and the graph is rotational symmetric about the origin, just like an electric fan. We now understand the definitions and properties of even and odd functions. But why do they have such a weird name? Let's take a look at some polynomials. For example, fx is equal to 5 times of x to the power 8 minus 6 times x to the power 4 plus 3 times of x squared plus 1. This polynomial is an even function. How do I find that out? Let's check it by using the definition of even functions. F of negative x is equal to 5 times of negative x to the power 8 minus 6 times of negative x to the power 4 plus 3 times of negative x squared plus 1. In this expression, because all the powers are even, negative x raised to an even power is simply positive x to that power. So this expression can be simplified to 5x to the power 8 minus 6x to the power 4 plus 3x squared plus 1, which is precisely the original function f of x. Because f of negative x is equal to f of x, we now verify that the original function is indeed an even function. Let's take a look at another polynomial. Gx is equal to 6x to the power 7 plus 4x to the power 5 minus 3x. This polynomial is an odd function. How do I know? Let's check the definition of an odd function. G of negative x is given by 6 negative x to the power 7 plus 4 times negative x to the power 5 minus 3 times negative x. Because all the powers are odd, negative x to an odd power is negative of x to that power. So we can simplify this polynomial into negative 6 times x to the power 7 minus 4 times x to the power 5 plus 3x, because of negative times negative becomes positive. If you look closely at this expression, you can see that every single sign is exactly a flip of gx. Therefore, this expression is precisely negative of gx. Because g of negative x is equal to negative of gx, we now know that this function is indeed an odd function. By now, you can probably guess where the names even and odd functions come from. If we have a polynomial function, then it is an even function if and only if all the powers are even numbers, such as x to the power 8, x to the power 4, x to the power 2, or x to the power 0. And it is an odd function if and only if all the powers are odd, such as x to the power 7, x to the power 5, and x to the power 1. If there's a mix of even and odd powers, then what will happen? Let's take a look at the following polynomial. H of x is equal to x squared plus x. Once again, to check whether a function is even or odd, what we should do is to plug in negative x into the function. X squared becomes negative x squared plus x becomes negative x. This can be simplified into x squared minus x. Notice that this is neither hx nor negative of hx. Therefore, this function h is neither even nor odd. We mentioned earlier in this video that there is a function that is both even and odd. What is that? Let's try to think about it in the following way. If I have a function f, it is even, then f of negative x should always be equal to f of x. At the same time, because this function f is odd, so f of negative x should always be equal to negative of fx. Because these two equations hold at the same time, the value fx is always equal to f of negative x, which in turn is equal to negative of fx. The only number that is equal to negative of itself is 0. So we have no choice but f of x is equal to 0 for every input x. Therefore, we have just proved that the only function that is both even and odd at the same time is the constant zero function. Thank you very much for watching this video. If you like it, please subscribe to our channel and we will learn more fun math together. Thank you.